So any scientist that is studying nature, for example, scientists that they are trying to produce a vaccine to fight a virus, or the scientists that are working against climate change, or scientists that are working to find a cure against cancer, all of them do the same thing as we watch in the video. They make observation and then form and test hypotheses. These are key steps for the scientific method. So first, make an observation, then ask a question, and then formulate a hypothesis. And this is fundamental. However, maybe one of the key components here is this, that it took a long time for the scientific method to develop, that is to do experiments. You have to not only make hypotheses, but doing experiments to confirm those hypotheses. Without the experimentation, we're actually not doing any science. And based on your experiment, you can or analyze your experiments, develop conclusions, and as you can see in the arrows, this start again and again. So you're asking constantly questions and testing them. And this is called scientific method, as you watch in the video. And three important things to tell you besides it is that the word science is derived from Latin that "an" means to know, and science is not a subject. What is a way of learning. It's a way of learning about the natural world around us. So we have biology, we have chemistry, we have physics, math, but all of them, what they use this scientific method, this way of testing hypotheses. And they have all these key components as I just talked and you watch in the video. Without experimentation, there is no scientific method. And why I say that? Because in class we will talk about conspiracy theories, and you will see that there are hundreds and hundreds of conspiracy theories, but without experiments, they don't mean anything. Now, another important point that I want to tell you is that a scientific method is an empirical method. It's empirical, so science get insight from their experience of the world. And in not all the fields they use this thing, but in science it's very important. For example, in philosophy, some type of logic. In math, they don't need it. In art, you don't need a scientific method, and they are valid fields. Yeah, for example, so as opposed to pure math, this is an example that they don't use in logic. There is no need to use scientific method. Some branches of philosophy they don't need, and in religion there is no need for a scientific method. So, however, in science, we always are going to need to have experiments to test our hypothesis. And if we don't have experiments, this is not a science. Please remember this. A hypothesis is a tentative answer to a well-framed question. So please remember that. This could be in the test. A hypothesis is a tentative answer to a well-framed question. And as we said before, a scientific hypothesis leads to predictions, and then they are tested by observations and experimentation. And as we just said. And based on an example that it was in your textbook, for example, you have an observation that your flashlight doesn't work. So the question that you can ask is, why doesn't your flashlight work? And the hypothesis is the battery is dead, so it doesn't have more electrical power. Or the other option is that the bulb is burned out in the flashlight. So this is not working. So you create two hypotheses. So, and the good thing about this is that both, as if you're watching the video, both are testable. You need to make an experiment to test that they are right. So for example, you can replace your flashlight bulb and if you can see if it works or not. And if it works, you can note that that possibly it was something related to your flashlight bulb. It was not related to the battery. So you reject this hypothesis and you said, like, there is something about the flashlight bulb. However, you only can say, these support the hypothesis that your bulb was burned out. However, they could be more hypotheses. So, for example, it doesn't completely prove that the bulb was burned out. Possibly it was that you didn't insert it in the right way, and you need to search to check all these hypotheses. What I was trying to do is being very picky about something very trivial, like a flashlight, and trying to do what we generally do. Is the batteries, but they are not working, or is the flashlight? And if it was the flashlight, what it could be. You need a new light bulb, or do you need to insert it in the proper way? And this is what scientists do all the time. That in the case of a scientist will be, for example, with cancer, a person that is sick of cancer, so they test what produced cancer. It was cigarettes, it was some type of food, and in that way they start testing those hypotheses to try to know what is the best way to answer that question. Now let's talk about another important topic. Imagine this. Somebody come with a conspiracy theory that a ghost it was responsible for the problem in your flashlight. And with all the conspiracy theories that we have right now, this will not be strange. So how the scientific method can help us to fight these crazy stories? So first thing that I have to tell you is that a hypothesis must be testable and falsifiable, and this is fundamental. When we are working with ghosts, when we're talking about ghosts, we're talking about supernatural forces, and we cannot make hypotheses that are testable or falsifiable with ghosts because there is no way to test if a ghost exists or not, because it's not in the natural world. It's more a supernatural force. In case that there's a hypothesis that a ghost fool with the flashlight, the problem is that more than say that is right or wrong, we cannot test this hypothesis because science only study natural forces. Supernatural forces and religious explanation are outside of the bounds of science. And remember, science is always based on evidence, while religion is based on faith. That a hypothesis must be testable and falsifiable. Now we can watch a video of Richard Feynman, who is a famous American theoretical physicist that done a lot of work in different fields, and actually he had even a Nobel Prize, and he's going to explain in more detail what is the thing. Before playing this video, I just want to tell you that he will talk about aliens and the scientific method, and I hope that you enjoy it. Now that we watched that video, I want to continue talking about questions that can and cannot be addressed by science. And remember that scientists need to be able to formulate testable hypotheses, because not all the hypotheses are testable, and we need to find ways to test those hypotheses. This is what makes a good experiment and a good scientist. And as this guy told us, the scientist told us, he talked about parsimony, and there are questions that are more likely that require less assumptions than other ones, and this is parsimony. When comparing two hypotheses, the more parsimonious is the one that requires you to make fewest and newest assumptions. So for example, when we were talking about Texas and we hear these hoof beats, the most likely that we think about the fewest assumption, that is about a horse, not about a zebra. The only option here is that if you're in Texas and you're in a zoo, maybe this could be right. However, in most of the cases in Texas, it will be a horse. Parsimony is another important feature of our hypothesis. Now let's talk about this question. Imagine that there's a patient in Winnipeg, and these are the symptoms: fever, pain under muscles, and they said, okay, what do you think that this person has? And you use this. What is the most parsimonious hypothesis? So in your diagnosis, this person has dengue or has just influenza a normal cold. Okay, so based on what we said, we can think that first, the dengue fever is generally happen in tropical areas, while influenza can happen everywhere. And this, for example, in Canada and Winnipeg, there is a lot of examples, especially in the area of Winnipeg. So the most likely in this case is that this person has influenza if she hasn't traveled over there to some of these countries and she has spent all the time. Why? Because it's the most parsimonious hypothesis, because it's the one that requires less assumptions. So as I said, the correct one will be influenza because it easily spread from one person to another one. And dengue is only restricted to tropical areas, and the mosquito cannot survive below plus 10. So this will be the most parsimonious hypothesis. Remember that parsimonious is not always correct. However, aiming for parsimony when developing a hypothesis is a good practice.